Okay, example 7B for the CBA review for Algebra 1. Again, I am going to use distributive property and multiply my 4 by both terms on the inside of my parentheses. So that's 4a plus 32 is greater than or equal to negative 12a plus 2. Negative 2 times negative 1 is positive 2. I'm going to add 12a to both sides. 16a plus 32 is greater than or equal to 2. Subtract 32 from both sides. 16a is greater than or equal to negative 30. Divide both sides by 16. A is greater than or equal to. Now I'm going to simplify my fraction. Both of these are divisible by 2, so that's negative 15 over 8. Again, on my number line, zeros here. This is actually just slightly under 2. So about there. Close circle, shading greater. Ooh, good. I can pick 0. All right, I'm still going to use my calculator just to check this, just to show you. So 4 times the quantity, 0 plus 8, is greater than or equal to. So I go right under the control, enter, and there's greater than or equal to. And then I have negative 2 times the quantity, 6a minus 1. Fabulous. I want to show you what happens when I check something that's not a solution. So we said negative 15/8 is just slightly bigger than negative 2. So I'm going to press up, up, enter, and I'm going to change these zeros to negative 2s just to show you what happens when it says something is false. So I'll make that negative 2 and also make sure that's a negative 2. Excuse me, 6 times negative 2. Okay, see how it says false? So if I put something in that's not shaded, it's going to tell me, nope, that's not right. All right. Simplify the expression. We have a square root, we have a coefficient, we have variables. So we have to use our prime factorization. 8 is 4 times 2, and 4 is 2 times 2. P squared, well, I'm just jumping ahead to my q's. Okay, p squared is p times p, and q to the 4th is 4 of them. And then I have an r. So I am looking for pairs. So I see I have a pair of 2s. I have 2 pairs of q's and a pair of p's. Now I'm not using this 4 because it's a composite number. I'm only talking about my primes, not using that 8. I'm only talking about my primes when I get to the end of my prime factorization. So I have a group of 2s. I have a group of p's. I have 2 groups of q. I have a leftover 2 and a leftover r. Those go on the inside underneath my radical. Same thing with 8b. 32 is 2 times 16. 16 is 8 times 2. 8 is 4 times 2. And 4 is 2 times 2. P to the 8th. Q to the 2nd. R to the 3rd. So I have a group of 2s there. I have a group of 2s there. I have a leftover 2. I have a group of R's. I have a group of Q's. And I should have 4 groups of P's. So I have 2 groups of 2, 4 groups of P, a group of Q's, a group of R's, and again, composite number, composite number, composite number, composite number, extra prime, and I have this extra R. I took this group of 2s and that group of 2s and multiplied them to get the 4. 120. There's multiple ways to break that down. I'm just going to do 12 times 10. It doesn't matter what you do. We should get the same prime factorization when we get down to the bottom. So again, 120 is composite, 12 is composite, 10 is composite, 6 is composite. So I'm just looking at my prime numbers. A group of 2s, that's it. There are 3 groups of W's and 2 groups of V's. I have a group of 2s. I have 3 groups of W. I have 2 groups of V's. I have a leftover, no letters, no variables, but just a 3, a 5, and a 2. So I'll multiply those. 3 times 5 times 2 is 30. 75 is 25 times 3. 25 is 5 times 5. There's a group. I'm not going to write out 10 W's. You should be able to see that there are 5 groups of pairs of W's. And V squared is just like it was over here. So V squared is 1 group. I have a group of 5s, and I have a leftover 3. Number 10 is the exact same thing. A 1/2 is the same thing as a square root. The numerator is the power, and the denominator is the root. So the square root of, and then all of this whole entire quantity to the first power. Square root to the first power. That's what the 1/2 means. So I'm simply doing the same exact thing as number 9. So 48 is 2 times 24. 24 is 2 times 12. 12 is 2 times 6. And 6 is 2 times 3. Group, group. A to the 3rd is going to have a group and a leftover. B to the 4th is going to have 2 groups. And C squared is going to have 1 group. So I have 2 times 2 is 4, a group of A's, 2 groups of B's, a group of C's, and a leftover 3, and a leftover A. The 3 and the A. Same thing over here. This is the square root of 90, A to the 7th, B to the 8th, C to the 4th. 90 is 9 times 10. 9 is 3 times... Oh, hello. 9 is 3 times 3. 10 is 5 times 2. Group, leftover, leftover. A to the 7th. Group, 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 leftover. B to the 8th, we know is 4 groups. C to the 4th, we know is 2 groups. So 3 groups of A's, 4 groups of B's, 2 groups of C's, a leftover 5 and 2, so 5 times 2 is 10, and then the leftover A. Okay, exponents. When I have exponential expressions, I have to look at my numerator and my denominator and simplify. So I see my coefficients that are being divided. So negative 30 divided by 6 is negative 5. I'm going to combine my x's in the numerator. So x to the 5th and x to the 3rd gives me x to the 8th. I'm going to add those exponents together. And y to the 2nd, y to the 4th becomes y to the 6th. Then we have the x squared y in the denominator. Really, I need to know that this is y to the 1st. When I'm dividing, I'm actually subtracting exponents like y to the 6th divided by y. There are 5 left. 8 minus 2 is 6. And now I don't even have anything left in my denominator. Everything's in the numerator. 8 minus 2 is 6. 6 minus 1 is 5. And then I have that negative 5 from dividing my coefficients. So same thing over here in the next example. Negative 40 divided by 8 is negative 5. I'm going to combine my x's. Same thing I'm going to add here, but it is 8 and negative 3. So 8 minus 3 is 5. 3 plus 6 is 9. Remember, that's y to the first. So subtracting, 5 minus 4 is 1, and 9 minus 1 is 8. If instead you thought about bringing that negative 3 down, you could do that. I will do that over here. You could make this x to the 8th, y to the 9th from still combining this 3 and the 6. But then you could bring this negative exponent down and then combine it here to make x to the 8th over x to the 7th, y to the 9th. And then you still have that y down there. And then 8 minus 7 is still this one that I had in my answer anyways. So either way. When I have a 0 power on a quantity, that whole entire quantity is equal to 1. And we know when we multiply by 1, that doesn't mean we change our answer at all. Times 1 just means itself. X to the 4th and y to the 3rd, those are different variables, so there's nothing I can do to further combine those. Same thing over here. This is x to the 6th, y to the 9th times 1. So that's just x to the 6th, y to the 9th. This one's a little tricky. You need to read it. If the area of a rectangle is 15x to the 3rd, y to the 8th, z to the 10th, and the width is 3x, y to the 6th, z to the 5th, what's the length? So remember, area is length times width. So to get length, we have to take the area and divide it by the width. Take the area and divide it by the width. So 15 divided by 3 is 5. 3 minus 1 is 2. 8 minus 6 is 2. And 10 minus 5 is 5. Another way we could think of it is, what do we have to multiply what they gave us by to get this? So 3 times what is 15? 5. X plus how many more x's would give us 3? 2. 6 plus how many more x's would give us 8? 2. 5 plus how many more z's would give us 10? 5. So let's look at this one. Again, area is length times width. We're given width, we need length, so we need to divide 25x to the 7th, y to the 12th, z to the 8th, divided by 5x, y to the 6th, z to the 5th. 25 divided by 5 is 5. 7 minus 1 is 6. 12 minus 6 is 6. And 8 minus 5 is 3. So checking it, is 5 times 5 25? Yes. Is 1 plus 6 7? Yes. Is 6 plus 6 12? Yes. And is 5 plus 3 8? Yes. So we got it. Simplify the expression. Now there's no equal sign here, so we're not moving anything to any other sides. We're just combining like terms. We're getting rid of the parentheses. We're eliminating parentheses using distributive property, and then we're combining like terms. So distributive property, ooh, 0.5, fun, we'll get to that. Okay, so 5x plus 4, negative 2x, negative 16, half of 2 is 1, half of negative 2 is negative 1. Our like terms, we have 5x minus 2x plus 1x. Now we're not doing anything to both sides. There are no sides here. You're just combining. 5 minus 2 plus 1. 5 minus 2 is 3. 3 plus 1 is 4. Constants. Positive 4 minus 16 minus 1. Positive 4 minus 16 is negative 12 plus 1 is negative 11. Did I do that right? 4 minus 16 minus 1. No, it's negative 13. What am I doing? Go away. Just double check that when you don't know, No harm in getting out the calculator. 4 minus 16 minus 1. It's been a long day. There, negative 13. Got it. Now I dropped my pen. Okay. All right, distributing my negative 3 gives me 6x plus 5 minus 3x minus 6. Distributing my 0.5, half of 4 is 2, and half of negative 6 is negative 3. Okay, so I have 6x, positive 6x minus 3x plus 2x. So 6 minus 3 is 3. 3 plus 2 is 5. And 5 minus 6 is negative 1, minus 3 is negative 4. Oops. All right. Write x to the fourth, y to the sixth, z to the second in expanded form. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2. 1, 2, 3, 4, 5. 1, 2, 1, 2, 3. All right. Good luck.